Hello everyone. In today's session we are going to discuss about differential equations of first order and first degree, and we'll obtain the solution in general as well as for a particular case. Now we knew that the general form of a differential equation of first order and first degree is given by f of x comma y comma dy by dx. So that equation contains either independent variable x, dependent variable y, and the derivative of first order and first degree. And the general solution of this first order and first degree differential equation is given by f of x comma y comma arbitrary constant c is equal to 0. And this solution is called as general solution, and if we give a particular value for arbitrary constant c, then this solution is called as particular solution. There are different methods available for solving the differential equations of first order and first degree. In this session, we are concentrating on solving the differential equations of first order and first degree by variable separable form. And after this, in the next sessions, we are going to discuss about reducible to variable separable form and few more, that is homogeneous equations, differential equations of homogeneous form and reducible to homogeneous, exact and reducible to exact differential equation, linear and reducible to linear differential equations, that too especially in the Bernoulli form. But in today's session we are restricting ourselves to variable separable form. So in this type of form, the given differential equation can be explicitly written into the group of terms having x along with dx and group of terms having y with dy, and we can separate these two groups and we can write in the form f of x into dx and g of y into dy, wherein we can integrate these two separately with respect to x and y. Now let us see some examples. The first one is solve dy by dx equal to 2y by x. Since it is a ratio of these two, we can easily separate the variables. How? Send this 2y to this side, and we should not keep derivative in the denominator. So let me send this 1 by dx to this side, that becomes dx, so that you will get dy by 2y is equal to dx by x. Now the terms involving y are in one group and the terms involving x are in the other group. So variables are separated, hence we can integrate this. So take integration on both sides. Then 1 by 2 is constant, so I can write this one outside. 1 by 2 into integral of dy by y is equal to integral of dx by x. What is the integral of 1 by y with respect to dy? Yes, it is log y. So half into log y is equal to log x plus integration constant. Either you can write simply c or log c. It will not have any effect. So log c, arbitrary constant is a log c. Now we know that we can apply log m plus n form. Log m plus log n is log mn. So log x plus log c is log xc, and this is of the form n log m. So we can take this power inside. We can take this one inside. Then it becomes log y to the power of half. Log gets cancelled, so you will get y to the power of half is equal to x into c, which is the required solution of the given differential equation. So in this fashion, we can separate the variables and we can obtain the solution in the differential equations which are coming under variable separable form. Now let us see the second example. In the second example, we are being given with 1 plus y square into dx plus 1 plus x square into dy is equal to 0. Now what we do is, we'll send one of the term to that side. Let us say 1 plus x square into dy to that side. Then this becomes 1 plus y square into dx is equal to minus of 1 plus x square into dy. Remember, with dx, we should have only terms of x. So, I don't want this 1 plus y square here. So, let me send this 1 plus y square to this side. That becomes divided by 1 plus y square. So, dx is remaining. Now, with dy, I want only terms of y. So, I don't have to keep this 1 plus x square. So, let me send this one to this side. That becomes dx divided by 1 plus x square. And this is equal to minus dy divided by 1 plus y square. Now the terms are separated, hence we can integrate this. So integrate on both sides. Then integral of this is equal to minus integral of this. But this is of the form integral of 1 by a square plus x square. Here a is 1. Therefore, we knew there is a general formula which says integral of 1 by a square plus x square is 1 by a into tan inverse x by a. But since a is 1, simply you will get 1 by 1 into tan inverse of x by 1. 1 by 1 is 1, therefore tan inverse of x. So integration of this is tan inverse of x. Similarly, minus, this is of the same form except instead of y, you are x, you are having y. So minus tan inverse of y plus integration constant c. So this is the required solution of the given differential equation. Now let's move on to next one. In the next one, they are given dy by dx equal to e to the power of x plus y plus x square into e to the power of y. Here, terms of x and y are mixed. And one more thing, we are having both the variables as a power of e, sum of power of e. First, we'll separate this. We knew that we can write e to the power of x plus y as e to the power of x into e to the power of y. So that in these two we can take out e to the power of y as common. Now this is product of two terms where one group consists of x and the other group consists of y. Hence we can easily separate the variables. How? Now in the left hand side we are having dy by dx. So I don't want to keep this 1 by dx. So let me send this 1 by dx to this side. So 1 by dx will become dx if you send it to this side. And I don't want to keep e to the power of y with dx. So let me send this e to the power of y to dy side. Then dy by e to the power of y is equal to e to the power of x plus x square into dx. Now the terms of y and x are separated. Hence I can integrate on both sides. Now integral of this is integral of dy by e to the power of y is equal to integral of e to the power of x plus x square into dx. Now, see, send this e to the power of y to numerator. That becomes integral of e to the power of minus y into dy is equal to integral of e to the power of x plus x square. Now, classical already Nandu classical already. Now this is e to the power of minus y. So integration of e to the power of minus y is e to the power of minus y by minus 1. And integration of e to the power of x is e to the power of x plus integration of x square is x cubed by 3 plus integration constant c. And this is the required solution of the given differential equation. Now let's move on to next problem. The next problem is x into square root of 1 plus y square into dx plus y into this is equal to 0. Now what we do is we send this term to this side so that you'll get x into square root of 1 plus y square into dx is equal to minus y into square root of 1 plus x square into dy. Now we know that with dx we should have only terms of x. So let me keep x as it is and let me send this square root of 1 plus y square to this side. So that this becomes divided by square root of 1 plus y square. And in this side, let me keep minus y into dy as it is, and let me send this square root of 1 plus x square to this side. So that this becomes x into dx divided by square root of 1 plus x square. Now the terms of x are in one group and the term which involves y are in the other group. Hence I can integrate this. So integrate on both sides and we get integral of this is equal to minus integral of this. Now in the first integral, derivative of x square is 2x. So x will come. So that's why I'll use substitution method. Let me take this 1 plus x square as some u. Then differentiate this. You will get du is equal to derivative of 1 is 0. Derivative of x square is 2x into dx. But here in the numerator I am having only x into dx. So let me keep x into dx as it is and send this 2 to this side. Therefore you will get du by 2 is equal to x into dx. Now make these substitutions in this first integral. Similarly in the second integral, let me take this 1 plus y square as v and differentiate this. You will get dv is equal to derivative of 1 is 0 plus derivative of y square is 2y into dy. But in the numerator I am having only y into dy. So let me keep that as it is and let me send this 2 to this side so that this becomes dv by 2. Now make all these substitutions in the corresponding integral and we'll get integration of your x into dx is du by 2 whole divided by square root of, and your 1 plus x square is u. So divided by square root of u is equal to minus of integration of your y into dy is dv by 2 whole divided by square root of your 1 plus y square is v. Now here 1 by 2 is constant, so let me write that one outside the integration. And we know that square root of u is nothing but u to the power of half. And if you send that one to numerator, that becomes u to the power of minus half into du is equal to minus. Here also 1 by 2 is constant and square root of v can be written as v to the power of half. If you send it to numerator, that becomes v to the power of minus half into dv. This is not du, this is dv. Now, we knew that we are having a formula integration of x to the power of n into dx. What is the integration of x to the power of n into dx? It is x to the power of n plus 1 divided by n plus 1. Apply that formula for both of this. Instead of x, we are having here u. Instead of n, minus half. Therefore, and these two half get cancels. So, u to the power of minus half plus 1 divided by minus half plus 1. N plus 1 divided by n plus 1 is equal to minus v to the power of minus half plus 1 divided by minus half plus 1 plus integration constant c. But your minus half plus 1 is half. So you will get u to the power of half divided by half is equal to minus v to the power of half divided by half plus integration constant c. But you know that u to the power of half is square root of u. Send this 1 by 2 to numerator, that becomes 2. 2 into square root of u is equal to minus 2 into square root of v plus integration constant c. Now send this one to this side and take 2 common and send that 2 to this side. That becomes divided by 2. So let us call that c by 2 as some c dash. You will get root u plus root v is equal to c dash. But this is not our required answer. Our answer should be in terms of x and y. So substitute back what is your u and what was your v. What was our u? It was square root of 1 plus x square plus square root of v is 1 plus y square is equal to c dash. This is the required solution. So in this fashion you have to solve given the problem which comes under variable separable form. Now let us see next one. In the next one they are given e to the power of x into tan y into dx plus 1 minus e to the power of x into secant square y into dy equal to 0. Send this term to this side, so you will get minus of this. Now I want only terms of x here, so I don't want tan y. Send this tan y to this side, that becomes divided by tan y. And send this 1 minus e to the power of x to this side. Then we got this. So here terms are separated, hence I can integrate them. So integration of this is equal to integration of this. Now in the first integral, I'll take 1 minus e to the power of x as some u. So that derivative of this is 0. Derivative of e to the power of x is e to the power of x only. So du is equal to minus e to the power of x into dx. But in the numerator I am having only e to the power of x into dx. So send this minus sign to this side. You will get minus du is equal to this. Whereas in the second integral, derivative of tan y is secant square y. So let me take v as tan y, then derivative is secant square into dy. Now make all these substitutions, then we'll get integration of du minus du by u is equal to minus integral dv by v. But let me keep this minus sign as it is. What is integration of 1 by u with respect to u? It is log u is equal to minus integration of 1 by v is log v plus integration constant log c. Now send this one to this side. You will get plus log v minus log u is equal to log c. Apply log m minus log n formula so that this becomes log m by n is equal to log c. Log get cancels. Your v by u is equal to c, and your v is tan u or tan y, and u is 1 minus e to the power of x. Substitute back them, and that will be equal to c, which is the required solution of the given differential equation. Now let us see another problem. Now this is dy by dx equal to sine of x plus y plus sine of x minus y. Here it is not possible to straight away separate the variable because two variables, their sum is present in the angle, here difference is present in the angle. So whenever problems of this form comes, sine minus sine, sine plus sine, cos minus cos, cos plus cos, we have to use the trigonometric formula. Now this is of the form sin c plus sin d, so that this sum becomes product. So you know how to convert the sum into product. So apply that formula. Sin c plus sin d is 2 sin, right? 2 sin c plus d by 2. C is x plus y, d is x minus y, right? C plus d by 2 into cos c minus d, minus of x minus y is minus x, minus into minus y is plus y. Now plus y minus y cancels, 2x by 2 is x, plus x minus x cancels, 2y by 2 is y. So you will get 2 sin x into cos y. Now this is very easy to separate because it is product. Now send this sin x to, sin cos y to this side, so that dy by cos y will come, and 1 by dx, if you come to send this to this side, 2 sin x into dx will come. Now we can easily integrate this. Integration of dy by cos y is equal to 2 times integration of sin x. But 1 by cos y is secant y. So what is the integration of secant y? It is log of secant y plus tan y is equal to, this is 2, integration of sin x is minus cos x plus integration constant c. This is the required solution. So in this fashion you can solve whenever the problem comes in variable separable form. You can separate the variable and you can obtain the general or particular solution. I had given some exercise, you work out and write them as assignment. Thank you.